Hi, we're going to talk about section 4.1, quadratic functions and transformations today. So get ready to take some notes. Remember everything we did with absolute value functions, where we moved them right and left and up and down and stretched them and compressed them and reflected them in the x-axis? We're going to do that same stuff with quadratic functions. Quadratic functions are functions that look like this. They make a parabola. All right? So let's do that. If you have f of x or y equals x squared, it's going to have a vertex 0, 0. That's just our basic vertex. So we're going to make a table. Always start with the vertex in the center. That vertex will always be in the center of your table, and you want to choose points around it. So if you choose points like -1, -2, 1, and 2, for sure you need like these 5 points here. It would be best to find the shape of the parabola. So to find the y value, you plug -1 into the function, which is x squared. Now remember that when you plug a -1 into something that's raised to a power, you really should use parentheses around that -1, because -1 squared is +1. But if you use your calculator and you just type in -1 squared, which is what you might think, the calculator is going to give you the wrong answer of -1, because it follows to the letter of the law the order of operations. It's going to square things first, because exponents come before multiplying. So it's going to square the 1 first and then multiply it by a negative. That'll give you the wrong answer of what you want. What you want is -1 squared. And you know that's a positive because a negative times a negative is a positive. So make sure you're putting parentheses around your negatives, these functions. So then if we put a -2 in here, -2 squared is +4. If we put a 1 in, we get 1. If we put a 2 in, we get 4. Notice the symmetry going on here. -1 has 1 and 1 has 1 for y value. So our vertex is at 0, 0. -1 is +1. -2 is +4. +1 is 1 and +2 is 4. Again, we've got symmetry around this line here. If we folded on this line, the left side and the right side would match up. I'll try to draw this. You guys can probably draw it better on paper than I can draw it here. That's your basic parabola. And the axis of symmetry is x equals, so x equals is vertical line, x equals 0, because the vertical line is at 0. It's our parent function of x squared. Now all we're going to do is change the function a little bit to transform it right and left, up and down, stretch it and compress it. So here's our parent function of x squared, and we're going to multiply it by a, some number in front. Do you remember what happens if you multiply by a number in front? It will stretch or compress the function. So if we're multiplying by a number between 0 and 1, that's going to compress it. So our description is that it's a compression by a factor of 1/2. So our basic function, our parent function of 0, 0, 1, 1, 2, 4, 2, -4, -1, 1, that basic function there is going to be compressed, so it's going to be fatter and wider. All right, our vertex, though, stays the same. Our vertex only moves if we move right or left or up or down, and this does not move it right or left or up or down. So our table is going to have a 0, 0 in the center. Now when you make your tables, I won't give you these numbers. You'll have to find them, so you make sure you put your vertex in the middle. Think about where your vertex is first. And then find some values around it. Find the y values. -1 squared is +1 times 1/2. So our y value there is 1/2. 1/2 times 1 squared is also 1/2. 1/2 times 2 squared. 2 squared is 4. 4 times 1/2 is 2. And using symmetry, that's going to be a 2 also. So our other function is going to be -2, 2, -1, 1/2, 0, 0, still our vertex, 1/2, 1, and 2, 2. So our parabola is squished down. Oh, I missed those dots. You guys do better, right? It's compressed. It's spread out. The axis of symmetry, though, is still at x equals 0. If I fold on this vertical line here, the left side and the right side will match up. Okay, what about f of x equals 3x squared? We've got a parent function. What's the 3 going to do to it? It'll stretch it by a factor of 3. So stretching by a factor of 3 is the description of what we did to it. The vertex is still at 0, 0. We're not adding or subtracting anything, so we're not moving it right or left or up or down. So we know our table is going to start at 0, 0, and then we're going to put in numbers like -1 squared is 3. -1 squared is 1 times 3 is 3. That's going to be a 3 also. So we've got negative 1, 3, 0, 0, positive 1, 3, and if you put in the 2, that's going to be 12, so that's going to be way up here. And using symmetry, we're going to have another one over here. So you can see that's stretched by a factor of 3. Axis of symmetry still at x equals 0. If we have a negative 3x squared, if I'm going too fast, have the sub pause this so that you guys can catch up. Vertex is still at 0, 0. That negative 3 doesn't change the vertex, so our table is still going to be at 0, 0 in the center, and we're going to choose the values around it, like negative 3 times negative 1 squared. So that's going to be negative 3. Negative 3 times 1 squared, negative 3. Did you guys remember that a negative out in front of the x squared would flip it, reflect it over the x-axis? So 0, 0, negative 1, negative 3, positive 1, negative 3, and the negative 12 way down here. It's pretty hard to draw these. Sorry, they're so bad, but you get the idea. And you can always graph them on your graphing calculator, but if you're going to do that, make sure you've got these points labeled on your graph so that I know that you know what those points are. Just at least the 3 around the vertex, the 4 around the vertex, 2 on each side. Let's reflect what happens when we change the value of a. How does the value of a affect the graph of the parabola? Remember, it stretches or compresses. If it's a number bigger than 1, it stretches. If it's between 0 and 1, it compresses. How does the value of a affect the vertex? Well, the vertex didn't move at all. It was always 0, 0. So remember, a does not affect the vertex. What about the maximum or the minimum? Hey, we didn't even talk about that. Let's go back. See this green graph? Does it have a maximum point or a minimum point? Well, this green graph's never going to go higher than 0, 0. But it will go lower. It'll keep going down forever. So it will never hit a minimum. It will never have a lowest point. But it will have a highest point. So the maximum of this graph is the highest value, that's the y value, of 0. This graph, the parent function of x squared, will have a minimum of 0. It'll go down to 0 but never lower, but it'll never have a max because it keeps going up higher and higher. All of these graphs have a minimum or a maximum based on which way they're facing. So if it's up like this, like a smile, it's going to have a minimum, and that minimum is right at that vertex. It's the y value of your vertex. All right, so we've talked about the minimum. Does a affect the minimum? Nope, it does not affect it because a doesn't move the graph up or down. How does the value of a affect the axis of symmetry? It doesn't. A does not move the graph right or left, so it's not going to change your axis of symmetry. All a does is stretches or compresses the graph. Well, what about if you add a 3 at the end? We should already know what happens there. It takes your graph and moves it up 3. 1, 2, 3. So everything's the same. You're going to go over 1 up 1. You're going to go over 2 up 3. You can use your vertex. Vertex is going to be at 0, but when you plug 0 in, 0 squared plus 3, that's going to be 3. So your vertex is at 0, 3. So you know it moves it up 3. You can use your calculator or just do the math to find those other values. Oops, that's a 4. And that's going to be a 4. And then negative 2 squared plus 3, it's going to be a 7. And that's going to be a 7. Does your axis of symmetry change? When you move graph up or down, nope, axis of symmetry stays the same. I'm sorry, x equals 0. Axis of symmetry stays the same. Describing the translation, it moved up 3, translated up 3. Just like we did with absolute value graphs. What about if it's inside? Remember when we had it inside the absolute value? It moved the opposite direction. So if it's plus 4, it's going to move left 4. So describing the translation, left 4. The vertex moves left 4. So now my vertex is here. My parabola is going to go like this. So does my vertex change? It sure does. Now it's at negative 4. Did it move up or down? Nope. So negative 4, 0. So make sure you start your table at negative 4, 0 and pick numbers around negative 4. It's very key to choose that vertex first. And you know where the vertex is because this tells you it moved right or left or up or down. Picking values around it, -5. So if you do -5 plus 4, that's going to be -1, and then you square it, +1. -3 plus 4 squared is going to be +1. -6 plus 4, that's -2 squared, that's going to be 4. So graphing it quickly here. Trying to keep this under 15 minutes because then I don't have to create another video. We'll just try to do it in one video. So it's the same parabola, just translated left. Did our axis of symmetry change? It sure did. Now my axis of symmetry is here. It's still an x equals equation. It's always going to be x equals, but now my x equals -4. Notice it equals the exact same value I have here for my vertex. It's the opposite of this. So vertex is always going to be HK. It's always the opposite of what's inside of here and the exact value here. The axis of symmetry is always going to be x equals that h. And what's A got to do with it? A stretches or compresses. And remember, if the number in front of A is less than 0, if the A is less than 0, like a -A, then we're going to have a graph that is reflected down like that. And if A is greater than 0, we're going to have just a smile, a regular smile, not a frown. When are we going to have a maximum value? If A is less than 0 and we have a frown, it's the maximum value is that vertex value of K, whatever the y value is your maximum. If we have a minimum, you're going to have a parabola facing up like this, and the minimum is the y value of the vertex, K. All right? And that is called vertex form. I don't know if you noticed the heading on that previous screen, but vertex form is when it's set up like this so that you can quickly see the vertex. Notice this has got a lot of stuff going on. What does the negative do? Remember, that reflects it in the x-axis. What does the 2 do? It stretches it because it's bigger than 1. X plus 1, that moves the graph left 1, and the plus 4 moves the graph up 4. So my vertex is at -1, +4. My axis of symmetry is x equals -1 because it's always the same as that x value. Do we have a max or a min? Well, this -2 means that we have a graph that's reflected in the x-axis. So we're going to have a maximum. And what's that maximum value? It's the vertex value of 4, the y value. Now domain and range we haven't talked about yet. Domain is all the x values. So this parabola, any x value we could plug in that we want to. There's no x value you can't plug in, so it's all reals. But think about the range. What y values are we going to have? This graph is going to go down forever, so every y value down forever, except the highest it's going to go is this point -1, 4. So y will never be higher than 4, but it could be equal to 4. So our range is y is less than or equal to 4. Using vertex form, looking at it, first of all, identify the constants. So we've got -2. H here is +1, it's the opposite. K is 3. Because our A is less than 0, the parabola opens down, so it's going to be like that. So the first thing you want to do is graph the vertex, which in our case is 1, 3, and then draw your axis of symmetry, which is x equals 1, and then pick a couple points around the x value of 1. So like 2 would be a good thing to plug in, and 0 is a good thing to plug in. So if I plug in 0, I'll get 0 minus 1 squared. That's going to be -1 squared is 1, and -2 times 1 is -2 plus 3 is 1. And this one will also be 1. So plot those and then sketch the curve. So what did we have? I forgot already. +1, 3. And then the other points we had were 0, 1, and 2, 1. 0, 1, and 2, 1. You should grab another point, but that's what it looks like. I'm trying to be quick here. We're almost done. All right. So there's a review of the vocabulary. The sub should pause it here until you all get that down. And then here's your assignment. Have a great day.